Hello again, and welcome to Junkyard Studios. This doesn't look like much, but this is going to be my reverb room, and I'd like to take you through each one of these devices. The first in this series, you can see there's three. The first in this series that I'm going to show you is my micro plate reverb. And I've always wanted a plate reverb. I never got to experience one firsthand. And they're extremely expensive and huge. And even this small one that I built is hard to find a place to put. But I kind of didn't plan on doing a video of these builds. So the plate reverb build is already done. But I'm going to run you through what I did and how I connected it and how it sounds. And the part that I have not done yet is the preamp control box, which I have an idea for, and you're just in time to see how that turns out. So stay tuned. Here is my plate reverb. This is out of the reverb closet I showed you before. A lot of the builds that I saw, they had steel frames, and I didn't have the ability to come up with a steel frame at the time. I still don't think I'd be able to. If I was to look for something, it'd be like a bed frame or something like that, because I can't weld. I can weld. I don't have the materials. I've welded before. All the stuff that I saw on the plate reverb, and you'll notice that the center driver is off center, and everything I saw from the reverbs, that's how they were set up. The center driver was a little off the center, so I followed that. I have files on a plate reverb. I think it's readily available through Google if you wanted to check it out. I don't know if I can post that stuff on my blog yet. If I can, I will. It's kind of somebody else's engineering. They just they had spent the time around so many plate reverbs that they could write up an article on how to build your own. And I certainly want you to be able to find that. You can see my wiring is kind of not complete. That mess over there is just my test rig. Those two little devices right there, those are little stick-on microphone amplifiers that I used to drive. I think that's just for the two drivers on the other side. I'll flip it around here in a minute. This whole frame, you can see, it was built around a pallet. This is the tension system for the plate. These are just hardware store turnbuckles, so you can tighten with an adjustable wrench at each angle. All I did was I cut more of this metal sheet away because there was a chunk taken out of it. So I squared it off and I took that extra piece and I cut these little triangles to strengthen the corners, and I just pop riveted them into place on both sides. So this turnbuckle only goes through actually this piece of wood back here. It's got that much room of adjustment because you want this plate to be pretty tight. I did that to stay as close to the original plate reverb design as I could, so that you could really stretch this out and give it some tension. And in the original designs, they had something probably more sophisticated, but still similar. This is what I came up with, and it works pretty good, and I'll show you that in a moment. On the other side, I basically just reinforced that pallet with a bunch of scrap wood and drilled holes here on there, and I just framed out more of that palette. My pickups are these little coin type stick-on speaker without a cone, and I didn't stick them on either, so I could move them around if I wanted to. There's enough magnet there to hold it. I did that for both sides. Those were pretty inexpensive. This is basically the same thing, but I can tighten it to the material. This is the driver, and it's a VidSonics Ghost. It works really, really well. I was really impressed with it. So that's basically it. Like I said, scrap wood. I put some casters that I had hanging around, some deck screws that I had hanging around. Turned out pretty good, and pretty soon you'll see how it sounds. And one of the things that I was concerned about was the size of the plate. I thought that would be part of the sound, like a bigger plate, and it probably is, but I was really impressed with even this small of a sheet, how that sounds. One of the main objectives of this video, I've already built the unit, kind of came in late on that. I tried to show you what I did with that. What I didn't do is build the preamp section. What you're looking at here is my prototype of it so far. And each one of these cards is from a Yamaha PM180. I didn't choose that because of all the hype behind the PM series or any of that. The only reason I chose it is because I had it. It was available and I could find a schematic on it. And I had 3 good channels. Good as far as I know. One would be the driver, and then the other 2 are going to be the pickup. So my schematics for this unit they're a little bit confusing. There's like a 22 volt and a 12 volt output for the whole unit, because this used to be like a big mixer with a bunch of different channels in it, a rack mixer, not like a typical mixer with faders and all that. This was just like one of those little rack units. Looking at the schematics and the components on the board, I'm still kind of having a little trouble determining what it is, because we've got 16 volts there, which should suggest that it's a 12 volt power supply. But over here, 47 at 25. I don't know if it takes the 22 and then drops it down somewhere in here. I don't think it does. I think it powers off the 12. So we're gonna find a decent 12 volt power supply, and we're gonna try and power this up as soon as I figure out these pins. That's another thing. In that manual, those pins are called out, but they're called out with weird names that don't make any sense to common schematics that you find naturally, because they probably didn't want you working on this. The only thing I was able to figure out without a doubt is that's where the microphone input comes in, which that's one of the strangest connections I've ever seen. So we'll see what kind of progress we make on that, and see what we can do with this. This has been sitting for a while. I pretty much did all the drilling, and that was about it. I got it pretty good. I have what each one of these knobs does on a photo on the computer. I think over here we got some equalization options. I'm pretty sure that's the volume. So we'll see how it turns out. I think it's going to be good, but I got to figure out what kind of voltage this is going to take. Even though that schematic is extra weird, I did finally figure it out. I believe, and the outside pins are the power, and all the center pins are the ground and the left and right signal out. And then we have our microphone signal there. What I have rigged up here is just a low power amplifier, which I had intended for another purpose, but didn't really serve that purpose very well. It doesn't 100% serve this purpose, but I have it rigged to our output. I'm trying to get a good spot here. It's hard to hear, but if I play with the microphone input, you should be able to hear me playing with it. So that's very low. But you can hear me tapping on that input. Maybe in a minute I can see if I'll get some sort of signal on that, but that proves to me that I'm going through the preamp. So this same test setup that I used before, I moved this pin that I was playing with over to one of the sides of the microphone input, and I sent my oscillator over to it. Now, you should be able to hear this a lot better. So that's telling me I'm at least getting signal through there and my connections are right. So one of the things that I don't know if I had touched on before is I have these clip leads. I use those all the time. Those are awesome to have. I'm actually thinking about buying more. You get quite a bit of them for just a couple of bucks, but having a ton of them is perfect. Like in this circumstance, I've already used 5 or 6 of them, and if I want to play around a little more and do some more tests, then I need more. I used some more clip leads here with a banana connector on the other end. It's a really good idea to have a lot of these hanging around, these different leads, and that's from our introduction video. That's what all of that is all the different leads that I've come across and I've made and I've hung on to. There's the schematic. I still haven't really figured out whether it's 22 or 12. The audio in the other video clip prior to this would suggest that it's 12. I didn't hear any distorted weirdness, but we weren't really hitting this circuit board with the kind of signal we expected to see. So things could change when we build it, play around a little more. Here's kind of what they called each pin, and I had assumed that was negative right there. They call ground E, which is weird because over on this side they call that pin E as well. But that's where I'm sending my positive voltage. And when I look at the ribbon associated to these channels, it says positive. R and L, I believe, are right and left. So there's negative, there's positive. Ground and right and left is what I'm assuming that means. But it works. So the next step is to desolder a bunch of those pins, put some wire into there, and start playing around with how it sounds and what kind of voltage we're expecting it to see. Alright, so we got some hideous noise, but we have guitar. My thought is the hideous noise is coming from the supply although there's a ton of bare wire there that could be catching all kinds of interference. But our connections are correct, so we can start with the build process. I had mentioned previously that my little amplifier that I had built, this one, wasn't suited for this job, and the reason is I could probably get signal with it, but it's too quiet to hear. That amp used to be a set of computer speakers, whereas this amp has a whole lot more gain. I wouldn't suggest, if you're going to make a test amp, I would not suggest using a set of computer speakers, especially the old pair that I did. I think there was something wrong with them, or there's still something wrong with them, because that amp is way too quiet, or it just wasn't made to handle what I'm trying to put it through. It was enough to give me an idea, but ultimately that other amp's probably just going to end up back on the project pile. I had another look at the schematic, and that connector, the very last pin, is 22 volts. And if you follow that, it's going down to our pin there. So that section right there, that's to all of our preamp cards. So I found that each one of these cards is 22 volts. The only thing I have is at 19 volts. So I'm kind of wondering if I should get a 22 volt supply, because I'm losing 3 volts, which probably means I'm losing decibels. It sounded pretty good on the test. I went through a couple different supplies. I ramped it up real slow. I started at 12, I went to 15, and then up to 19 just to be safe. And each time the noise went away and it got better. That and the schematic kind of pushed me towards 22 volts. While I figure out what I'm going to do with that supply, this is kind of the dry fit. The cards are going to sit here. The power supply, hopefully whichever one I choose, is going to be about that same size. And then this is going to be our output section. I saved the output section from the mixer. That's the program, I think it was the program outs. Those are the output transformers. And the next thing I'm going to do is create a panel there, because this was like a card slot panel and had a bunch of holes in it. It didn't really fit so well. So I'm going to cut up a blank piece there, drill some holes, put all of our input, output, this is probably going to be all output, put all of our output sections here. I've drilled out the panel for the back of the case. I'm going to drill and tap some securing screws into there to keep it in place. Probably going to clean up these solder joints. Another thing that I've done, I've put marks in for my output transformers. I'm not going to drill that yet. I have it marked on my panel as well. I'm not 100% sure it's going to work, but it's all passive. I think as long as the signal that goes to it is what it originally was looking for in the schematic, which I think these were hanging off of the program amp, I think it would be the same signal. I'm going to rig it up and try it before I actually sink it into my project. I'm also going to temporarily put the 19 volt supply into this box until I get everything kind of situated. I think the loss of those 3 volts is going to be probably a problem with how this sounds. I know these preamps aren't really, hi-fi or anything like that. They're kind of install preamps. Some people go crazy about them. I'm just wanting a clean signal that I can send to and return into my DAW from the plate. If I need any EQ or any of that afterwards, I can do that within my programs. I really just want a basic clean signal. If it gets me anything else, great, but if it's not good, it goes back on the pile. Another thing I want to play around with, this is about 4 amps for this power supply. If you think about it, we're putting 3 preamp cards in there. I'm not sure what kind of amperage it's looking for, but I got a feeling 3 amps will probably cover it, and those preamp circuits won't draw more than they need. So I'm not worried about over voltage. This ridiculous mess you're looking at is my test rig for the plate reverb. There's our favorite practice amp over there with a temporary supply coming to a little stick-on microphone preamplifier, and that's going up to our center driver, because the third card in my little preamp box, it's not working 100% yet. It's I think there might be an issue. I guess I had to find an issue out of 3 cards, you know, figures. But these other 2 cards are working pretty good on the higher supply. All of that cable mess those are going to be our 2 pickup channels on either end of the plate, and they're all just clipped together with the output section, but it works, and I'm going to show you right now. Let's go to the other setting on the output, see if that changes anything. I think that almost made it quieter. Try the other output on the transformers. Oh, I think that signal's about the same. So that's not too bad for some junk I had laying around and a little bit of hardware parts. That signal was definitely usable. It was a little buzzy, which I'm blaming all of that mess. I'm going to clean that up now. Now that I know it works, I can solder all this stuff in permanently and really fix it. The signal was a little weak, and I think it's probably that stick-on mic amp not performing to the standards we need it to, because that center driver is basically a speaker, and this is trying to send it a low Z output. It's probably not doing it too well, but it was enough for the test rig. I think we'll probably get a better signal out of that third card when that comes back. So I'm going to take all this apart. I'm going to solder everything in, put it all together in its last form, and then do another test run and see if we get a better result. I've run into a design snag with our preamp box. These two cards are being used on the pickup, and those pickups are wired like microphones. So these preamps will probably work fine for that part. The third preamp card here, which I haven't installed yet, that needs to drive an 8 ohm load for our driver. So I've come into a problem with that, because these preamps don't actually drive an 8 ohm load. So what I'm going to try is I found this U820B board, which I believe has an 8 ohm output. It's basically another amplifier, so the preamp is going to hit the amp and drive that 8 ohm load, and then hopefully we'll get that volume back that we lost on the first test run. I'm wiring up our plate reverb preamp box, getting it ready for our test run of the third card with a 8 ohm output for the driver. And while I was installing this card and getting it wired up, I noticed something. Down here on the card, you'll see, if we move all these wires out of the way, these are kind of temporarily in place. You see that each one of these 3 cap cans here have an insulated resistor next to each one of them. If we go over to the card that I've been having a problem with, and again move all the cables out of the way, we see those three same capacitors, each with an insulated resistor, except for the center one. That resistor is missing, and that could possibly be the problem that we're having with this card, why it doesn't work correctly. That resistor must have been broken off in transportation, because all three of these cards have just kind of been floating around in a box since I got them. And there was a reason that the unit that I pulled these from was taken out of service anyway. We could speculate 1,000 different endings, but what we do know from looking at the other cards is there really should be that resistor there. So I'm going to go ahead and find that value, and actually looking right at it now, it is a different value. Get in there, you can see the two outside resistors are the same, look like they're the same value. They have the same color striping. That center resistor that's missing has a different value, a different striping, as you can see between the two cards. So I'm going to find that resistor, replace it, and see if that was our problem. And hopefully it is, and we can get this card moving and have something ready for this plate reverb. Another thing I'd like to point out with these resistors is the other ones that we see on the board are straight to the board. There's no gap. With these and the missing resistor around these capacitors, they're raised from the board and they're insulated. They did that for a reason. We could speculate a bunch of different reasons and try and figure out why, without knowing what their original design intent was. What we can take away from this is they did it for a purpose, and we should continue it on the missing resistor here. We shouldn't put it flat to the board. It might have been a noise issue, it might have been conductivity, it might have been any number of reasons. But if they put it in that way, we should put it back that way without knowing what they had designed. Because designs can certainly be improved in later days when more knowledge is accessible. I have a high doubt that Yamaha didn't know what they were doing. I think they did. So I'm just going to duplicate what they've done, knowing that their designs at that time were probably pretty solid. But we can keep that in mind in the future and maybe look and see if they're, find out the purpose of it. That might be outside of the scope of this video, however. I put the third card into the box and I wired everything up, and I went to try our little board. I don't know that it's giving us an 8 ohm load. According to some of the schematics I've seen, it should. Maybe some capacitors are missing or something, because it really didn't drive our driver. I think I'm going to have to take this and maybe just use it as a preamp box, or reconsider how I'm going to use this. In the meantime, I think we're going to put the plate in the reverb closet, keep this configuration here, and just give it a send return with 1 amp, with these two feeds going back to a preamp in the DAW area. I might do another video on this depending on how this goes. I think that's about all we've got for now. So thank you for watching, and build one of your own plates. It's extra fun. It doesn't cost a whole lot. Keep an eye out for our videos. We've got a couple in the pipe. Probably gonna have a few coming up here. As I finish them, like, share, subscribe, and thank you for watching. Well, rather than give you no payoff, I rigged this up. And I did have some video, but a server error happened. Pretty cool. I did record the plate back at the DAW to give you an idea. Until that other preamp box gets figured out, this is just going to have to do. We've got a tube front end and then just our 2 returns back to the DAW. looking at our waveforms, looks like I might have a problem on one of the channels. That's probably not on the plate end, that's probably on my preamplifier here. But this is what our plate sounds like. Pretty good with that. I'd like that preamp box to kind of get figured out, but for now, that'll do.